So in this video, we're going to go through different operations with complex numbers, so adding, subtracting, multiplying, and dividing. So first, we're just going to make sure that we remember how to work with these imaginary numbers where you have a negative underneath the square root sign. So we take that negative and we say, oh, that should be plus, and we stick an I in the front. So 6 plus I times the square root of 16 would be 6 plus, the square root of 16 is 4, so 6 plus 4i. When we are adding complex numbers, now these i's are not variables. They represent imaginary numbers, so we're not going to really think of them as variables, but they kind of work similar to variables when you are adding and subtracting because you have to combine like terms. So a complex number has the two pieces. It has the real part and the imaginary part, and you just want to make sure that when you write your final answer, you put your real numbers together and you put your imaginary numbers together. So you're keeping your real terms and your fake terms separate, basically. So here, since we're adding, there's no number to distribute to the parentheses, there's no negative to distribute, so those parentheses were unnecessary. They just used them to say that this represented the first complex number, this represented the second complex number. So I can go ahead and rewrite that problem without parentheses, and then I can go ahead and just combine my like terms. So 2 plus 3 gives you 5, and I and 3i makes 4i. With subtracting, it's going to be a very similar type of problem, except in this case, these second set of parentheses really do make a difference because we need to take that negative and we need to distribute it. So negative 8 and negative 7i. The parentheses for the first two don't really make any difference for the problem because there was no number to distribute, there was no negative to distribute to the first set of parentheses. So now we can go ahead and combine our like terms. So we've got negative 20 and negative 8, or sorry, negative 12 and negative 8, which makes negative 20. And then we have 10i and negative 7i, which makes 3i. And you'll notice that in each problem, I'm being careful to write my real portion of the complex number first, and the imaginary portion of the complex number always goes second. All right, next we're going to do multiplication. So just like you would expect, if you have a number in the front, it should be distributed. So 3i times 4 gives you 12i. 3i times 2i gives you 6i squared. And this is where we have to remember that an I squared actually represents a negative 1. So they put it over here, and just make sure we're always remembering that, we're keeping that in our heads. I squared equals negative 1. It's important to remember. So I'm going to say that I squared is actually a negative 1. So 12i plus negative 6. And we want to make sure that we write this in the correct order. So the real portion of the complex number comes first, and the imaginary portion of the complex number comes second. And I can switch the order of these as long as I keep the negative number negative, and that was a positive number, so I have to keep that positive. All right. With this next one, again, we have a multiplication problem, and this multiplication problem is going to use either foiling or you could multiply using a box. So I have negative 5 multiplied by 1 first. So negative 5 times 1 is negative 5. Negative 5 times negative 6i is the next thing. So negative 5 times negative 6i is positive 30i. Next, we'll do the inside. So 4i times 1 is positive 4i. And then last, we'll do 4i times negative 6i. And that is negative 24i squared. So again, we're going to say, okay, that I squared is actually a negative 1. And so that makes this right here has become positive 24. So negative 24 times negative 1 has become positive 24. So 24 plus negative 5 gives you 19. So those are our real numbers. And then our imaginary numbers are 30i plus 4i, which gives you 34i. All right, so next, these are the difficult ones. They don't show up necessarily all the time. I would say the multiplying is super important. We're going to do that for today's assignment where we're doing operations with numbers, but we're also going to do it later when we start looking at graphing things. The division ones show up sometimes, but not always. So if you don't like them, that's okay, but we want to try to understand them as best we can. So when you have a simple denominator like this, like we only have an imaginary number on the denominator, we don't have a complex number down there, it's just imaginary. Anytime that's the case, you can just multiply the top by I and the bottom by I. And the reason we have to do that is because it is not considered proper to have an I on the bottom of a fraction. So we can't leave an I there. If we multiply the top of the fraction by I and the bottom of the fraction by I, then that's going to give us 4i on the top, and on the bottom it's going to give us 3i squared. And as you guys know, the I squared actually represents a negative 1. So that gives us 4i on the top and negative 3 on the bottom. And now this answer is considered to be more proper because there's no more I on the denominator. Now when you put a negative with a fraction, you could leave the negative on the bottom with the 3 if you wanted, or you could move it to the top with the 4i if you wanted, or you could put it out front in the middle. It doesn't matter where the negative is in the fraction as long as there is one. All right. Now this last one is the one you're going to have to memorize this. There's no like cute little saying or song that I have for you, but you have to multiply it by what is called the conjugate. And the conjugate is the exact same thing as the denominator, but you change the sign in the middle specifically. So the middle had a plus, so we're going to make the middle have a minus. All right, and then we're multiplying these together. So that means that on the top, we're going to have to distribute the 5, because that's how you multiply fractions, is you multiply the tops together and you multiply the bottoms together. So 5 multiplied by 3 is 15. 5 multiplied by I is 5i. And then on the bottom, we're actually going to have to FOIL those. So 3 times 3 is 9. 3 times negative I is negative 3i. Positive I times 3 is positive 3i. And positive I times negative I is negative I squared. Okay, so what you'll notice is negative 3i and positive 3i cancel out, and they will do that every single time. Whenever we do these problems, the middle two things will always cancel out. Always, always, always. Okay? Next, we can say we've got a negative of I squared. We know that I squared is a negative 1. So we have a negative of negative 1, which gives you positive 1. And 9 plus 1 is 10. All right. And what you guys might notice is that every single one of these numbers is divisible by 5. So it's good to always go through and do that. It only works if every single number is divisible by the same thing. So I can go ahead and divide everything by 5. That gives me 3 minus 1i, or you can just put I, divided by 2. And that is the final answer. So if we were to think about the steps for this, first we multiplied by the conjugate. Then we had to actually multiply the tops and actually multiply the bottoms. And we fixed that. We made sure that our I squared was a negative 1. And we wrote our answer. And sometimes this answer will be your final answer and you'll be completely done. But sometimes you will look at the numbers and notice that all of them are divisible by the same thing. And if that's the case, then you would actually divide that number out.